Here we are given the graph of y equals g of x and asked to graph y equals g of x plus 1. Starting with y equals g of x, we see that the x has been replaced by x plus 1. This is going to affect the graph of y equals g of x horizontally. As a matter of fact, it is going to move the graph left. One. So negative 2, 0 will go to negative 3, 0. Negative 1, 1 will go to negative 2, 1. 0, 0 will go to negative 1, 0. 2, 2 will go to 1, 2. And 4, 0 will go to 3, 0. Connecting the dots gives us the blue function, which is the graph of y equals g of x plus 1. So now let's go down to part B. In part B, we want to graph y equals g of the opposite of x. So we start with y equals g of x. Again, x is going to be replaced this time by g of the opposite of x. Again, the effect on the graph will be horizontal. Each x is being replaced by its opposite in the ordered pairs, and so the graph is going to be reflected horizontally across or over the y-axis. So negative 2, 0 goes to 2, 0. Negative 1, 1 goes to 1, 1. 0, 0 stays where it is, since negative 1 times 0 is 0. 2, 2 is going to go to negative 2, 2. And 4, 0 is going to go to negative 4, 0. So the graph created by joining these dots is the required graph for y equals g of the opposite of x. It is the reflection of the original graph over the y-axis. Let's move to part C now. Where we have y equals g of x minus 2. So starting with y equals g of x, for the third time, we're replacing the x, this time with x minus 2. This again causes a horizontal change in the graph, and in this case, the graph is going to move 2 to the right, since it's looking for its values to the left. And so negative 2, 0 will go to 0, 0. Negative 1, 1 will go to 1, 1. 0, 0 will go to 2, 0. 2, 2 will go to 4, 2. And 4, 0 will go to 6, 0. Connecting these points gives us the graph that results when y equals g of x is slid 2 units to the right. This is y equals g of x minus 2. Now in part D, we have y equals 2 less than g of x. So starting with y equals g of x, we subtract 2 from each g of x. So notice the g of x are intact. We're subtracting 2 from the y values. This is going to have the effect of moving the original graph down 2. Now we have to be a little careful here. Our graph isn't really made to go down 2, but we're going to go from negative 2, 0 to negative 2, negative 2, from negative 1, 1 to negative 1, minus 1, from 0, 0 to 0, negative 2, from 2, 2 to 2, 0, and from 4, 0 to 4, negative 2. The resulting blue graph is the graph of y equals g of x, all minus 2. So we've gone down 2 with all of the y values. Subtracted 2 from each y value. Now E, we have y equals g of x going to y equals the opposite of g of x, or negative 1 times g of x. This time each of the y coordinates in the ordered pairs are being replaced by their opposites, and so we are going to be reflecting vertically over the x-axis. The y's are changing. The points on the x-axis will not be affected because when we multiply those y values, 0 times negative 1 is still 0. But negative 1, 1 will go to negative 1, negative 1, and 2, 2 will go to negative 2, negative 2, or will go to 2, negative 2. So the blue graph is a reflection of the original red graph across the x-axis. It is the graph of y equals the opposite of g of x. We have one last one, and this is y equals 2 times g of x, which says each of the y values is being multiplied by 2. The g of x is intact in both. So what's going to happen is we're going to stretch the curve vertically by a factor of 2. Again, the points on the x-axis will remain there because when we multiply their y coordinates of 0 by 2, we get 0 again. But negative 1, 1 will go to negative 1, 2, and 2, 2 will go to 2, 4. And so this resulting blue graph is the graph of y equals 2 times g of x.